All right, let me see if I can help you with this altitude and geometric mean thing. Let's first make sure we understand this. The geometric mean is when you have a proportion, you have extremes are the outer pieces and the means are the inner pieces of the proportion. What a geometric mean is when the two means are the same number. In this case, is the geometric mean of this proportion because the means are the same number. So that's what a geometric mean. That ends up being the mean is equal to, the two means are equal of the proportion. And if you cross multiply, you get n squared equals AB right here. Now, so in a diagram, if you have a right triangle, like I have here, and then you have an altitude, I'm going to call that altitude A, its length, the length of the altitude, is related to the length of the hypotenuse. Well, but the altitude itself is related to the parts of the hypotenuse. So it's related to these parts, G and F, because it breaks up, the altitude itself breaks the altitude, or breaks the hypotenuse into G and F. So the deal is, the length of the altitude, which in this case is A, is the geometric mean. So I put an A on both those spots for the means of those two parts, the G and the F. So the altitude is the geometric mean between the parts of the altitude. Now the other pieces of this, oh yeah, we can multiply A squared is equal to GF once you cross multiply. So the altitude times itself equals the product of G and F is what we end up getting here. And so those numbers there go together. The legs of the right triangle are also geometric means related to the hypotenuse. This leg over here, which I'm calling L, is a geometric mean, so I'm going to put it here and here, the parts of the proportion, but it's a geometric mean between this closest part of the altitude and the entire, not of the altitude, of the entire hypotenuse and the entire hypotenuse. Okay, G, the part of the hypotenuse that's closest to and the entire hypotenuse. So we end up with this proportion. L is the geometric mean between the part and a part. So those pieces go together. And the same is true for the other leg, but it goes with, K goes with the part of the hypotenuse that's closest to it, which in this case is F. Okay? So we end up with these equations that happen. The leg squared equals this part G times the hypotenuse H. K squared equals this part F times the hypotenuse H is what ends up happening. So on number 11 on that assignment, on the 8.2 and 8.3 practice 2, what do we have? Well, we have a right triangle with an altitude, so this is where the geometric mean will come into play. That altitude, or the hypotenuse, is broken into 3 and 9. X is the leg, so I'm going to apply this guy down here, this proportion. X is the geometric mean between 3 and the entire hypotenuse. So X is the geometric mean, it goes there and there. 3 and 12 is what goes the rest of it. So it's the part closest to it and then the entire hypotenuse. Cross multiply and solve, X is equal to 6. For Y, it's the same thing. It's just going to use Y instead, I'm sorry, it's going to use 9 instead of 3, the part that's closest to it. So Y is the geometric mean between 9 and 12. That's how you end up solving it. Square root of 108 ends up being 6 square root of 3. The other one you asked a question about, number 13, it's the same idea except for which parts of this, we got an altitude in a right triangle. Which parts do we have here? Well, we have hypotenuse has been broken into 15 and 4. X is the altitude, so X is the geometric mean between those two parts. There's that proportion. To solve for Y, we're going to use the part it's closest to and the entire one. So we end up with 15 over 19. I'll let you go from there, but that's hopefully a better breakdown of how it works. Time for class to end. I hope that helps. Let me know if you still have any more questions. Talk to you soon.